Hi, this is chapter 12, part 1. The chapter is on alkanes, which basically have a carbon and hydrogens alone. So methane is the simplest hydrocarbon that we can think of, which has one carbon and four hydrogens. They have the formula one carbon, four hydrogens, which fits the formula CnH2n plus 2. So you have one carbon and then 2 times 2 plus 2 times 1 plus 2, a total of 4. So CH4 is methane. You have longer hydrocarbons, which are such as undecane, which is found in cockroaches. Cockroaches give off undecane to sort of attract other cockroaches to one another. So alkanes are hydrocarbons that have only carbon, 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 hydrogen. They have a general formula CH2n plus 2. There are one carbon alkanes such as methane, but there are also undecane which are longer carbon hydrogen chains. What we see in undecane is a saturated alkane, and we also see that they are acyclic or not ring. Cycloalkanes are also possible. These are rings. As I have pointed out in class and elsewhere, each of these vertices is a carbon. In this particular way of showing, I have not shown you the hydrogens. This carbon, for instance, has 2 bonds, and then it will need 4 total, so it will have 2 more hydrogens that we have not shown. But since it is a compound, even though it's ring-shaped, it is a compound with carbon and hydrogen, it is a cycloalkane. This should be distinguished from this type of compound with a circle or alternating double bonds within them. Both of these are the same compound and they're benzene. It is not to be confused with a cycloalkane. Cycloalkanes have the general formula CnH2n, and there is not the 2 hydrogens in addition. Again, simple alkanes include methane, ethane with 2 carbon atoms, and we notice that there is a pattern. We have the A and E to indicate the alkane, we have meth to indicate 1 carbon atom, eth to indicate 2 carbon atoms, prop to indicate 3 carbon atoms, but to indicate 4 carbon atoms, pent to indicate 5 carbon atoms. Therefore, pentane would be a 5 carbon atom alkane, 5 carbon atoms with 12 hydrogens, because the formula CnH2n plus 2. So 10 plus 2, 12 for pentane. So 5 carbon atoms would be pent, and since it's an alkane, we will do pentane. Pentane can exist as, butane is a 4 carbon atom alkane, which can have branches. And these branches are equally, are different from the actual straight chain butane. These are called isomers of one another. The way to label them is the butane and isobutane. They both have the same formula, but what is different about them is that the carbons and the hydrogens, they're not arranged in a straight chain here. There is a little bit of branching, and so they're different. This is another representation of the same structure. Here you have 4 carbons in a row. Here you have 3 carbons in one branch. Isomers have 2 different compounds, same molecular formula. What I've shown you is constitutional isomers as opposed to stereoisomers, which stereoisomers are D and L, which you will see in carbohydrate chapter, or even before that. So as the number of carbon atoms increases, the number of isomers that are possible also increase. With butane, we see butane and isobutane. With pentane, we see pentane, isopentane, and neopentane. Again, they're all the same formula, but a different arrangement atoms. Here is more: hexane, heptane, octane, nonane, decane. Again, you see the A and E at the end of it, but depending, the blue stuff is depending on how many carbons there are, and that will be the general. So anything with hex will have 6 carbon atoms. If the last few letters indicate that it's